Good evening, everyone. Today I will be presenting to you the effect of bat materials on ball speed. Firstly, I will tell you some things about me. My name is Jacob Shelton. I currently attend Gretna High School, and I plan to attend Virginia Tech in the fall in order to study general engineering. Now, some reasons for why I chose this topic. One, I've played baseball for several years, and through this I've discovered a passion for the game itself. And through this passion, I've discovered I want to find the best bat for myself. As well, with this study, we can gain an idea of what material is the most beneficial when trying to create a good bat. Furthermore, you can find what material is the most dangerous when creating bats, and both of these things can help manufacturers when trying to create a good bat. As well, I find it unfair for some people to be able to buy whatever bat they want within the game, while others cannot. So I want to try to make the purchasing process just a little bit easier by trying to eliminate some bats. The first topic of my study I will be talking about are bats themselves. Bats have came a long way in the game as they've gone from wood to aluminum and to now what has become composite bats. And throughout this time period, an increase in batted ball velocity has been noticed, but it's unknown whether or not the material changes are the reason why. Going further, there are also limiting factors when discussing bats. One big limiting factor is sweet spots. And what a sweet spot is the length of the bat when it is at its widest. And a sweet spot can significantly increase how good a bat is because it makes it much easier to hit a ball. As well, with a big sweet spot, your bat is less dense, making it easier to swing. Going further, another limiting factor is another limiting factor is warming up. Warming up can be ignored if this is kept completely constant. Going further on to the topic of bats, I will talk about durability. Durability is very important when discussing bats as it decides how long your bat will actually last and when you have to buy a new one. But this can typically be ignored when discussing new metal bats, as metal bats have typically been seen to last many years. And finally, when discussing bats, there is batted ball velocity. This is the initial impact that comes from the bat impacting the ball. This is measured in miles per hour and can easily be found using simple formulas. The next topic I will discuss are baseballs. Baseballs play a significant role in this study due to how much can change about a hit if something is different about a ball. First is the construction. The construction of a baseball matters because any different material being used can change how the bat hits the ball due to some materials being softer or harder than others. Along with this, we have orientation. Past studies have found that orientation along with spin can change how bats hit balls due to the bat either hitting the blank area of the ball or the lace. As well, the spin prior to the hit can change how it spins after the hit. And lastly, there is speed, which most likely causes the most change out of these three things because the faster the ball is going prior to the hit, the faster it will bounce off of the bat. And there are also some methodological considerations within this study, which are backed up. Firstly, I will be using a high school baseball player as my participant due to high schoolers representing a majority of the baseball population because most quit after high school. High school players are also at a point in their career where they fully understand the game and the mechanics behind it, so no flaws should be apparent through a lack of experience. Furthermore, another methodological consideration is a baseball tee. The reason I have chosen to use a baseball tee for this experiment is because everything mentioned earlier about a baseball can be kept constant. This is because we can easily place a ball on the tee in the exact same location and orientation every single time. As well, the tee is stationary, so the ball will be at a speed of 0 prior to the hit. Now, the justification for my study comes from a lack of research focused on ball velocity when discussing bats. Typically, researchers have been focused on how well the bats actually swing or how durable they are. And this gap could also likely be due to how new composite bats are to the game itself. But on top of this gap, my study will help gain knowledge on how safe different types of bats are. And it will also give players insight on how each bat hits and how they perform. Now, the research question for my study goes as, how do baseball bat materials affect batted ball velocity? And looking into my hypotheses, I came up with the null hypothesis by looking into prior research and deciding it's very possible that aluminum bats and composite bats can simply hit the same. As for my research hypothesis, I came up with this by taking an educated guess on what prior knowledge from baseball has taught me. The null hypothesis goes as, if baseballs are hit with different bat materials, then there will be a difference, and then there will not be a difference in the average batted ball velocity. The research hypothesis goes as, if baseballs are hit with different bat materials, then there will be a difference in the average batted ball velocity. For my study's variables, the independent variable is the materials used for the baseball bats. The dependent is the velocity of the baseballs after the hit. The control was a wooden bat, and the main constants were the aspects and features of the bats and baseballs, along with the tee position, which, as you can see in the displayed picture, was kept constant by using this stationary plate, and the camera position, which was kept constant by using a wooden pole. Along with this, my study did contain one participant, which is a current high school baseball player, who was given a debriefing form after the experimentation. Along with this, as previously mentioned, a high school baseball player is experienced enough to perform in a successful experiment. As well, consent was obtained from the participant's parents, and Dr. Jones. Now, the materials included in this study consisted of 2 metal baseball bats along with 1 wooden bat, with these representing my sample, and the population being all regulation baseball bats. Then there were baseballs, which held an amount of 30, a hitting tee, camera, batting cage, and a tape measure. The procedure for this study started with me measuring out 10 feet markers, which were used as guides for the camera when measuring the velocity of the balls. After setting this up, I set up the tee, camera itself, and baseballs, which were kept in a constant position throughout the procedure. And once everything was set up and ready, I let my participant warm up for 10 minutes, and they warmed up before every single bat. And after warming up, I recorded 30 hits for each bat. And after each set of 30 hits, I let my participant take a 1-hour break in order to try to keep their stamina controlled. And after recording every hit for every bat, raw data was compiled and a statistical analysis was conducted. Next, we can talk about the results. And the results show each batted ball velocity being compared to one another. Specifically, when looking at this graph, we can look at the means of each bat, where we can see that wood averaged the slowest velocity, aluminum came next, and composite averaged the highest velocity. And while this would typically reject my null hypothesis, the p-values must be looked into to know this for certain. But before that, we can look into how tight the groupings were. And doing this can show which bat was actually the most consistent. Looking at the graph, it's very easy to see that the aluminum bat was much more consistent than the wood and composite. However, when looking at this, it is apparent that the wood and composite bats had higher maximums, which may mean that it is harder to hit a ball as hard with an aluminum bat. But finally, we can analyze the data. For the data analysis, I chose to use a one-way ANOVA due to my study meeting the requirements of having 3 groups being compared to one another. First, we can see that there was not a significant difference with wood and aluminum at a p-value of 0.0 at a significance level of 0.05. As well, there was a significant difference between wood and composite. However, when looking into what my study aimed to compare, being aluminum and composite, we see that there was not enough evidence to definitely say that composite was better, which does not reject my null hypothesis. Through this study, I discovered that aluminum bats are significantly more consistent than composite. However, composite bats did have the upper hand when it came to just how hard they could actually hit. Furthermore, metal bats were overall seen better than wood due to the aluminum bat being way more consistent and averaging a just slightly higher velocity. As well, the composite bat averaged a much higher velocity. And lastly, this study gives insight to which type of bat a player would prefer based off of how each bat performed. The limitations for this study relate to how a limited amount of bats were used and how more swings could have been recorded. As well, it was very difficult to keep the swings exactly the same each time with a real player hitting these balls. Furthermore, sweet spots on every bat were not exactly the same, And lastly, the experiment could have benefited from a camera which had higher frames per second. As for future research, studies should focus on having more bats as well as recording more swings with preferably a camera with higher frames per second. As well, the swing should be attempted to keep as constant as possible. What this study has taught me is that for one, I should never be afraid to ask anyone for help or anyone for questions. And something else I've realized is that processes like this become a lot easier when I organize everything and plan out everything and keep everything easy to access. Most importantly, I've realized that you should always try to plan ahead and not procrastinate, as this can easily make my life and yours a lot more difficult than it needs to be. Finally, I do want to give a special thanks to Ms. Long, Ms. Gravitt, my parents, my sister, and my participant. Are there any questions? Mr. Taylor.
Yeah, so you mentioned using the camera and frames per second, and I saw in your materials you had a tape measure. Do you mind just explaining to me briefly how you calculated the exit velocity of the ball off of that?
So essentially, I measured out 10 feet markers, which you can convert to miles using simple formulas. And when doing this, you essentially measured how much time it took the ball to move 10 feet, and you turned the time into hours and the length into miles, and then you define the miles per hour.